Hi YouTube, Tim Eckert here. In this video, we're going to continue with my Algebra 1 Honors Finals review. We're on problem 11. Let's take a look. So it says solve the following system algebraically and graphically showing all work. So we have y equals x plus 1 and y equals x squared plus 4x plus 3. So both of these equal y, so I'm going to say x plus 1, that's going to equal x squared plus 4x plus 3. And I want to get one side of this equation equal to 0. And I can do that by subtracting both x and 1 from both sides. And I'm just going to line these up like so. So x minus x is 0. 1 minus 1 is 0, so the left-hand side of this equation becomes 0. That equals x squared plus 4x minus 1x, so plus 3x, plus 2. And we can factor this. So this factors to, well, the factors of 2 are 1 and 2, and we have plus and plus here, so I'm going to look at positive factors. 1 plus 2 adds to 3, so I can write the right-hand side in factored form as 0 equals x plus 1 times x plus 2. I can then solve for x by setting x plus 1 equal to 0. Subtracting 1 from both sides. 1 minus 1 is 0, so I get just x on the left-hand side equals negative 1. I want the y value that goes along with this, so I'll say y equals x, which is negative 1 plus 1. Take the top equations easier. So negative 1 plus 1 is 0. So one of my solutions is negative 1, 0. It's going to be a point of intersection between these two equations. I can also set x plus 2 equal to 0. And subtract 2 from both sides. 2 minus 2 is 0, so I get just x equals negative 2. And then, again, y equals x, and negative 2 plus 1. Take that top equation. So negative 2 plus 1 is going to be negative 1. So my other solution here is going to be negative 2, negative 1. So I'm going to have negative 2, negative 1 as one of my solutions, and negative 1, 0 as my other solution. Now I took up a lot of space doing this problem, so I'm going to have to erase. So what I would do right now, if I were you, is pause the video, make sure you write everything down, and then when we come on back, I'll have erased this stuff. Okay, let's look at problem 12. We've got a function f of x equals 3x minus 2. And it tells us we want to create a table of input-output pairs for x equals 0, 1, 2, 3, and 4. So I'm going to have a table with, let me make a better x there, that wasn't that good, with my x values and also my f of x values. Sometimes on the tables you indicate the actual whole function, so equals 3x minus 2. We're running out of room though. I'm just going to leave it as f of x. And let's create our table. So we have 0, 1, 2, 3, and 4. Okay, so for 0, 3 times 0 is 0. And then we subtract 2, we get negative 2 here. For 1, 3 times 1 is 3, minus 2 is 1. For 2, 3 times 2 is 6, minus 2 is 4. And then you notice we're increasing by 3 each time here. So negative 2 plus 3 is 1. 1 plus 3 is 4. And that's because our slope is 3. So every time I go up 1 in x, I go up 3 in y. So I'm just going to add 3 to get 7 here, and then add 3 to get 10 here. And there we go. That's my input-output table for problem 12. All right, let's keep going. Problem 13. We're given a function for f of x equals 4 to the x power, so an exponential function. We want to create a table of input-output pairs for x equals 0 through 4. So 0, 1, 2, 3, and 4. So 4 to the 0 power is going to be, well, any non-zero base to the 0 power is 1. And then when we do x equals 1, so that's 4 to the first power, which is 4. Then we do 2, which is 4 to the second power, 4 times 4, which is 16. Then we do 3. 4 to the third power is 64. So 4 times 4 times 4. And if we do 4 to the fourth power, which would be 4 to the third power times 4, that's 64 times 4. So 4 times 4 is 16. Bring up the 1. 4 times 6 is 24. Plus 1 is 256. So down here we have 256. All right, let's keep going. Problem 14. Write the recursive formula and find the next term in the sequence. And this is an arithmetic sequence. We are increasing by 3, so we have a common difference of 3. Each time we go up. So our recursive formula is going to be a sub n equals a sub n minus 1. So the nth term equals the term before it plus the common difference, 3. And we also probably, for our recursive definition, we want to indicate the first term, which is negative 1. Okay. So that way you know where the sequence starts, and yeah, basically all this says is to get the next term, take the previous term and add 3. Okay. Let's go to problem 15. So problem 15, we have to find the 119th term of the following sequence. So we have an arithmetic sequence. So we go from 3 to 7, 7 to 11. So we increase by 4 each time. So our common difference is 4. So D equals 4. Our first term is 3. And the number of terms that we're dealing with in this problem is 119. So we're going to use the explicit definition, which is, in general terms, the nth term equals the first term plus n minus 1 times the common difference, d. Okay, so we don't know what the nth term is. Well, we know it's the 119th term, so the 119th term, we don't know the value, is going to be the first term, 3, plus 119 minus 1. Now it's minus 1 because, and then we times 3. It's minus 1 because we only add 3 after the first term. So for the second term, we add 3 once. For the third term, we take the first term and add through, oh, sorry, it's not 3. What am I doing? No, it was right there. It's the common difference 4. Hopefully you caught that before I did. To get to the second term, we add 4 to the first term once. To get to the third term, we add 4 to the first term twice. That's why we have this -1 here. Okay, so this is going to be 3 plus 118 times 4. Let's bring up Desmos. So we have 3 plus 118 times 4, and that gives us 475. So the 119th term is equal to 475. All right, let's do problem 16 here. All right, so we're going to simplify the cube root of -125 x cubed y to the 9th z cubed. So the cube root of -125 is going to be -5, because if we multiply -5 times -5 times -5, we get -125. All right. Now, the cube root of x cubed is just x, because x times x times x is x cubed. The cube root of y to the 9th is y cubed. So we take the exponent here, and we're going to divide it by 3. So we get y cubed, and then cube root of z cubed is just z. So we have -5x y cubed z is our solution here. All right, let's keep going. All right, so problem 17, we're simplifying 243 x to the 10th, y to the 15th to the -1/5 power. So to make that the positive 1/5 power, we could put that in a fraction. We could say this is 1 over 243 x to the 10th, y to the 15th to the positive 1/5 power. Okay, so that's like a fifth root. So the fifth root of 243 is 3, because if I take 5 3's and multiply them together, I'm going to get 243. Try it out in your calculator if you don't trust me. So the fifth root of 243 is 3. Fifth root of x to the 10th is x squared. We do 10 times 1/5, x squared. And the fifth root of y to the 15th is y cubed, because 15 times 1/5. All right, so our solution here is 3x squared y cubed. All right, next one, we're going to factor x squared plus 9x plus 20. And we've got the number in front of x squared equal to 1. So we can just list the factors of 20. And we have a positive and a positive here, so I'm going to stick to positive factors. So we could do 1 times 20, 2 times 10, or 4 times 5, and positive 4 times positive 5, that equals positive 20, but adds to positive 9. So I'm going to select this pair here, and I'm going to write my factored form as x plus 4 times x plus 5. And that's our solution to that one. And let's do a couple more, and then let's conclude part 2 of the Algebra 1 Honors finals review. So let's look at number 19. So here we're factoring x squared minus 18 or minus 8x plus 15 because we have a negative coefficient in front of x here. Or actually, well, it's 8. It's minus 8 because we have minus 8 here and a positive 15 here. We're going to list negative factors of positive 15. So I can multiply negative 1 times negative 15, but that adds to negative 16, so that doesn't work. Or we could do negative 3 times negative 5. That multiplies to positive 15. Let me fix that 5 there. But adds to negative 8. So we're going to want to use this pair and write our factored form as x. My x's are getting a little sad. So we got x minus 3 times x minus 5. And that's the factored form there. All right. In problem 20, we want to factor x squared minus 81. So if they say that x squared is a squared and that 81 is b squared, well, this is going to follow that difference of squares pattern, and that pattern is a squared minus b squared. That factors into a plus b times a minus b. Okay? So if a squared equals x squared and b squared equals 81, well, we can factor this. We can figure out what a and b are pretty easily. To figure out what a is, we'll take the square root of both sides here. And square root of a squared is a. Square root of x squared is x. And then to figure out what b is, take the square root of both sides over here. Square root of b squared is b, and square root of 81 is 9. So this is going to factor to the quantity a plus b times a minus b. That's our general form. So in this case, a is x and b is 9. So it factors to the quantity x plus 9 times x minus 9. And that's my solution for problem 20. So I'm going to stop the video right here. Hopefully this video was helpful to you. If it was, please like and subscribe.